So chapter 2, the first half at any rate, is going to be all about solving equations. If in pre-algebra we got through chapter 10, then this first half of chapter 2 will be entirely review. Actually, I should say if we got to chapter 10 in pre-algebra, then all of chapter 2 will be review. If we didn't, well, we'll get through it. So first up is solving one-step equations, something we've been doing for a while now. We use opposite operations, inverse operations. So I want x by itself, which means this negative 10's got to go across the equal sign. We do that by adding 10, and obviously 10 plus 4 is 14. Here I've got fractions, but that's not a problem because they have the same denominator. So I can just add those. 2/5 and 1/5 is 3/5 for m. Decimals. Not a problem, we just got to make sure we write them carefully and line them up. It's subtraction, so we're going to do addition. 6 plus 2 is 8. Drop your decimal point. 5 plus 3 is also 8. So we get 8.8. When there's addition, we will subtract the number across. So here x is 2. Some more addition, so we will subtract. Again, with decimals, being careful to line up our decimal points. 7 minus 4 is 3. You really should put the 0 in front. It just helps make the decimal point that much more obvious. This next problem says addition, but it's a negative 8 that we're moving across the equal sign. Because it is a negative number, we have to add it to cancel it out. Negative 8 and 8 makes 0, so b is alone like we want it to be. 2 plus 8 is 10. Down here, these are division problems. We have k divided by negative 5 equals negative 4. We undo division by multiplying. So we'll multiply both sides by negative 5. Those cancel. Negative 5 times negative 4 is positive 20. So 20 is k. Here we're dividing by 3, so we're going to multiply by 3 to make this work. 1.5 times 3, you can think of that as 15 times 3, that's 45, and then slap the decimal point in the middle. And then we've got some division or multiplication problems that'll be solved using division. So when you have 7 times x, divide both sides by 7. Here x is 8. For this problem, we're going to divide both sides by negative 2. And you're going to leave that alone. W is negative 13 halves. You could make that negative 6.5, negative 6.5, but you don't have to. In Algebra 1, we are allowed to have improper fractions. So leave it alone. And then the one that everybody hates, fractions with the variables. So 5/9 v is 5/9 times v. We would normally say, hey, I've got to divide to solve. Small problem, other than my iPad not liking it when I'm at the bottom of the page. Actually, maybe if I do this, it'll be okay. We can't divide by a fraction. So we multiply by its inverse. So instead of dividing by 5/9, we're going to multiply by 9/5. When I do that on this side, most of you are probably going to want to put the 35 over 1. That's fine. Feel free. Simplify if you can, and you absolutely can. The 5 becomes 1. And the 35 becomes 7. 7 times 9 is 63. This next problem is very much the same kind of thing, but it might help if you rewrite it and split the y out of the 4/3, which you're allowed to do. As long as the variable is in the numerator like this, 4y divided by 3, you can make it 4/3 y. I apologize for my iPad doing this. I still haven't figured out how to get it to calm down and stay at the bottom of a page. We've got 4/3 times y, so we will multiply by the inverse, which is 3/4. Everything on the right would cancel except for y, which is what we want. On the left side, nothing simplifies, so we just multiply. 3 times 5 is 15, 4 times 2 is 8, and we will leave it as 15/8.